हर एक वॉइस रिकॉर्डिंग नहीं होगा. I think we don't need this. Okay, thanks.
Just press the record button. This is the record button.
Thanks, guys.
So it's already recording.
Getting the batteries. Well, today we shall move a step ahead. Any issues with yesterday? All those things that we have learned, we've learned random variables, continuous random variables of different kinds. Anything that you wish to say about them? The normal distribution part? What part of normal distribution? Huh? What part of normal distribution you want me to repeat? Standard normal distribution? What is standard normal distribution? Standard normal distribution is, see, x follows normal with the mean mu, variance sigma square is a normal distribution, right? Right. Now, you perhaps draw this kind of a curve and say that this is mu, this is 1 sigma square, 1, 2 sigma, sorry, not square, 3 sigma, 1, negative 1 sigma, negative 2 sigma, negative 3 sigma. This is your normal distribution. Now, sigma will take some value, right? Say, suppose I talk about intelligence, then typically I believe that mu is 110 and sigma is 50. So, the normal distribution that I have is 1 upon sigma root 2 pi. I can find probability of x by 1 upon sigma root 2 pi e raised to negative x minus mu upon 2 sigma square, right? So this is how I would find the probabilities associated with x. Now the problem with this is, suppose I take one intelligence test. Now this is scaled to 110 and 15. Okay. Now suppose I take an intelligence test, like say Cattle's culture fair intelligence test scale 2. This scale has a different mean and different standard deviation. If I take WISC 4, it will have a different mean and different standard deviation. So what we generally do in psychological assessment is we scale them to a common scale. Most often these scales are either Z transformations or T scales. T scales are, you set the mean to be 50 and standard deviation to be 10, right? So that's a T scale. Or then some old-fashioned tests used to have a STAN or STANINE, which will have a mean of 5 or 5.5 and stuff like that. So what you're basically doing is you are rescaling the data to some kind of a mean and some specific standard deviation. Now, generally, if we, now suppose I got a score, suppose there's an intelligence test, say test 1 is, intelligence test 1 has mean of say 30 and standard deviation of say 5. This is intelligence test 2, which is mean equals to say 70 and sigma equals to 10. Okay. Now I found somebody who's got a score of say this one individual. Okay. This individual number 1, first participant has got a score of 32 on this. There's a second participant who comes in, who says that he has got 75 on the second test. Now, I wish to compare the two participants. How do I do that? How do I do that? So, the easiest way of, and we know because this means and variances will be different because each of the tests has different number of items, right? Some tests are shorter, some tests are longer. So, given that these are fairly equivalent IQ tests in all other respects, I wish to know who is better off among the two. So what do? I need to rescale their values and I should be able to compare those values. Why I can't compare 32 and 75? Because the 75 has come on a distribution that has a mean 70, sigma square 100, sigma is equal to 10. This values come on a mean of say 30 with a sigma square of 25, right? So I can't compare them directly. So I need to actually convert these values to a distribution which is identical mean and identical sigma squares. Now I believe that the distribution of both the tests are normal, okay? Both of them are normally distributed with mean mu, variance sigma square. So the variance here is 25, variance is 100, right? So once I have this, what I can do is I can convert them to a distribution which I call Z. What is Z? X minus mu upon sigma. Now Z is also normally distributed. Z is also normally distributed. The only difference between Z and normal and standard normal is Z is normally distributed with a mean 0, variance 1. Okay? So if I convert these values to a distribution which is mean 0, variance 1, then I should be able to compare these two values. Say I take first value, I compute Z for this, then it is my X is 32 minus mu is 30 upon 5, that is 2 upon 5 is whatever this fraction is, right? 0.4, right? The Z for this is 75 minus 70 upon 10, which is 5 upon 10.5, right? Now, what I can say is the Z of participant 1 is 0.4 and Z of participant 2 is 0.5. Now what is Z? Z is something that follows normal distribution with a mean 0, variance 1. So participant 1 is having a score of 0.4 on 0.4 and participant 2 is having a score of 0.5. Whose score is bigger? Participant 2, right? 75 or 0.5 are the same things. Okay, 0.5 is a Z of 75, right? So what I can say is when there were 32 and 75, they were not comparable, but if they were normally distributed with a mean mu and variance sigma square, I can rescale them or convert them into what is called a Z, standard normal distribution, which follows normal with a mean 0 and 1. Now both the scores are scaled to a distribution which is mean 0, variance 1, and so I can now compare both the scores because they have identical mean and identical variance. So both scores now come from a distribution that has mean 0, variance 1, and so I can say that this score is bigger than this score, and this score is bigger than this score, 0.5 is bigger than 0.4, and hence participant 2 is slightly better off than participant 1 when it comes to intelligence. So this is the simple application part of it. Okay, so if I set mean to be 0, mu to be 0, this will be 0, this will be 1, this will be 1, and so the function that I get, I bring this 2 out, so I get 1/2. So then I would write sigma root 2 pi, but sigma is 1, so I need not write that sigma. Sigma is 1, so I need not write sigma. Then negative 1/2, e raised to negative 1/2. 1/2 is this 2 I'm getting out, so would be 1/2. And x minus mu bracket square upon sigma or this whole square would be z square, right? X minus mu upon sigma is z, so is z square. This is what standard normal is. This is what standard normal is, right? So I convert normal into standard normal by simple transformation, which is displayed here, right? I think that takes care of your question. Okay. Standard normal is very useful because we use standard normal distribution at various places. Basically in psychometrics we need standard normal because we scale values accordingly. We also need standard normal to find probabilities under normal curve. As I said last time, the tables that you get to see of area under normal distribution at the end of most of the statistical textbooks are standard normal tables, right? So this is one of the useful ways of conceptualizing it. Anything else? Rest is fine. The z conversion into chi-square into f into t times of. We have not spoken about beta and gamma much and Weibull much, but beta is very theoretically very important distribution. Gamma is a distribution that uses gamma function. Gamma function is a very useful function. You can express normal distribution by simply using gamma function instead of writing this function. Beta is also a very useful distribution. In fact, if you set some of the parameters of beta to 0 or 1, you get beta into uniform, you get beta into some other distribution. So beta can actually take different distributions. Beta becomes a particular distribution or another distribution as some of the parameters of the distribution beta are given a value 0 or 1 or so on and so forth. So beta is highly useful distribution. Not discussing it because for most of the applications that we are about to discuss, we don't need to actually need a very explicit knowledge of beta, but I recommend that you guys just browse through the beta, gamma, Weibull distributions because they are otherwise theoretically very valuable things. Okay. If there's nothing that we need to discuss about continuous time variables and so forth, then we can actually discuss conditional probabilities.
So,
Yeah.
before you told us yesterday, how do you solve the expectation x for x square?
Perhaps I give you one more day to do it and solve it. I want you to solve it because we have done most of the hard work that is required in the class. So you need to spend some time. See, you would to get a quick fix answer, you will find it online. There are proofs.com and stuff like that, and you will find proofs for almost everything. It's no fun. Spend some time, try and solve it on your own. The learnings that you will have are much bigger than simply getting it from a textbook or from some online site or I'm doing it on board. Well, you will copy it But if you keep on solving it, you would perhaps learn a lot than simply learning the correct answer of it. You learn a lot from mistakes.